Hi everyone, welcome back to Small Engine Tutorial. Today I'm going to show you how to test ignition coil for a small engine. Have you tried testing ignition coil before? No? That's fine. I'm going to show you how to test ignition coil today. Yes? That's good. But you can still stay with me and I'll show you different ways of testing ignition coil from the conventional way of testing, and we both learn together. So sometimes you test ignition coil with all the correct readings and correct procedures, but after testing the engine still won't run. Then after replacing with the new ignition coil, it works fine, and you're surprised why it behaves that way. So this video today will cover this more in-depth way of different ways of testing ignition coil, and we cover those different scenarios. And let's get started. The basic method of testing ignition coil is to measure the resistance reading of the coil. So to measure the resistance reading of the coil, you need a multimeter with ohms reading. You set your multimeter to 20k. So testing ignition coil is you place one of the probe, either negative or positive, it doesn't matter. There's no polarity between the two. So you place one of the probe into the body of the ignition coil and the other end into the ignition lead, and you're expecting a reading of a range in kilo ohms from 2k to 15k. So you have 4.5 kilo ohms. So because some of the Briggs & Stratton different types of ignition coil, the resistance reading, the ohmic reading, is sometimes lower. It's in a range of 4k, and some are in range of 10 or 15k. So with this ignition coil in the left hand side, so this one has an internal resistance of, we don't know yet, so looks the same, and we have to check whether they're both internally the coil are the same. So measuring the resistance reading of this one, we just place this one probe in here and in here, and you get 9.3 kilo ohms. So this ignition coil has a problem. Sometimes when you flex the lead, you lost the connection. So these two coil with the resistance reading, this one is around 9k or nearly 10k. Sometimes it doesn't read, and this one is 4.7. So lost a reading here. Okay, 4.5. Okay, so they are both the same coil. So also to test ignition coil is to measure this is the most common method of testing ignition coil, is to measure between the high voltage to this control contact here. So you expect to have a reading of the same reading when you place the probe to here, to the ground. So how do we know if it is working? By just taking those measurements. You have 4k, and also here you have 4k, and assuming that the spec of this one is exactly the same as what the manufacturer's specifications. So like for this one it's 10k, it's within the manufacturer's specifications, and if you measure this one to here, so sometimes you lost the reading. So that's no reading, but if you move this one, you get reading. So there's a lost contact inside, so 9.29. And then when you measure from to this contact point here, you also have the same reading. So how do you know that this coil is working? Assuming that this one is good, there's no lost contact. And what is this one? So you wonder what is this? This is going to the control switch, to the stop switch, and this is shorting. To stop the engine, you short this one from here to there. So you short these 2 points here. But how do we know that this one's working? This one's good. So maybe it's open. Let's have a look. Let's set the multimeter to 200 ohms, and let's measure this one. So if you measure this one from this point to this point here, you get 1.3 ohms. sometimes 0.8. And if you short this lead here, you get the same thing. It's like shorted. I know why. How does the ignition coil works if these two end here are already shorted, and if you short them together, it stops the engine. You're surprised why. And this is what the video is showing you, what this one here, and how to test this properly. So there's another method of testing this one. We call it inductance measurement, or in henries or millihenries. So to do that, you must have a multimeter with inductance capability in Henry and millihenry. So with this type of multimeter, I have this inductance reading. So we set this one to Henry. So it might be confusing for now. It's a bit confusing, but we will go more in depth on schematic diagram, what is the actual connection and what we are actually testing. So just to illustrate, so we will make a drawing here. Okay, so this is our coil. This is our core, like that one, and we have this coil here, and this is the high voltage. This is a high voltage going into the plug. This is more than 1,000 turns here, and this end sometimes comes out and then it continues with a few turns, and this end here is connected to the body of the ignition coil. So now this is our control. So because of the number of turns here is very small, so let's say it's only 10 turns to 20 turns. So with that number of turns, you cannot measure the resistance reading, but it's a coil. And here it's roughly you're looking around 15,000 turns for the high voltage side. So some we call it this one the primary, but actually it's not a primary. They're both secondary winding or a single winding, because the primary winding is virtually right here where the magnetic field is induced into the core from the what do you call this, the flywheel ignition. So the magnetic field is induced, and then it produces a magnetic field into the coil, and when it collapses, it creates a magnetic electric current or voltage, and it creates high voltage there. So now when measuring from here to there with the resistance reading, so when we measure from here to there, it gives us a 1.5 or 0.1 ohm, which is sometimes you can't tell whether it's shorted or not. But what happens if internally shorted, this coil is internally shorted, you still get the same reading, and now you cannot tell whether that one is good or not by testing with the multimeter in ohms reading, because they are the same reading, but actually it's now the coil is faulty. So we have a coil here which also a faulty coil, which will give you a good example. So the other way, the best method to test this coil is to use an inductance meter with in Henry and millihenries. So now, so we have to test this coil and we will see the difference. So we set this one to millihenry, and we're now on millihenry or inductance mode. Then if we connect this one, you short this multimeter, you get a reading of 0.002 millihenry, or 0, almost in shorted. So Now if you measure this one to any part of the body of the ignition coil, like here, because this is one complete core, and you expect to be 0.000, which is what we see. But if you measure this one to this pin here, you get roughly 2.25 millihenries, which gives you the inductance of this coil, which gives you an indication that this coil is good. So that's why when measuring with using the resistance reading here in ohms, no matter how you test this and that, it gives you almost zero reading, 0.8 ohm. And if you short this one, you also have the same reading, 0.8 ohms or 0.4 ohms. So you can't test that way. So the only way to test that is to use a inductance meter in millihenry. So right here, the test is one and that one. So you can also use an inductance meter in millihenry, not in millihenry but in henries, especially when testing the high voltage from here to there. So you test this one in henry, you get 6.9. Okay, 6.9. Now we go to the other side. This is 6.9 millihenry with 4.7, roughly 4.5, 4.7 K of internal resistance or equivalent resistance. This one has an equivalent resistance of a total equivalent resistance plus this resistance here of roughly 10K. But let's measure what is the actual inductance of this coil, the high voltage coil. So we place this one here and measure the center of the pin, and we're still in henry, and we have the same reading, pretty much the same. It's 6.2 henries. So 6.2 henries. So you're surprised why this one and that one, these two coils, pretty much the same inductance reading. The number of inductance is, the more inductance, that means the more high voltage will produce. And also the main purpose of this internal resistor here is for the AMI, or the suppression of the electromagnetic interference, so to prevent any unwanted noise or unwanted radiated emissions noise, especially in gigahertz, that will interfere with other devices, which this is regulated with the CISPRO 12 standard for automotive. And also maybe this one also tested to CISPRO 32, but this is a different way. This is a more ways of testing the standard. But anyway, so you're surprised the both have the same inductance reading. So the representative block diagram for this one is, we have this internal resistance here. So aside from that, we also have this resistance on the plug, which this is roughly 4K. When you measure this one, is 4K or 6K. So this is 4K and this is 10K. So the difference is 6K. But internally, the inductance are pretty much the same. So the inductance is here. So when we represent the network, inductance network, it will be looks like this. So that one has an internal resistance, equivalent resistance, plus resistance on the plug. So this one's we read 6.2 Henry. So this internal resistance here we read 4.5K, and when we measure the resistance here with other ignition coil, we get roughly 9.6K. But internally, when we measure the inductance of these two different ignition coil, they have the same inductance of 6.2 henries. Now, what is the difference between the two? So the difference is this one has extra resistance on this end here, which is roughly, let's round this one off to 10K, and this is round off to 4.5 or 4K. So you get roughly 4.5k here to 6k, and this is going to the high voltage, this is going to the ground. Okay, so this is going to the HV or high voltage. So this is the best method to test ignition coil, especially for this end here. So some of the ignition coil, most of the ignition coil is, you have this, the high voltage here, and then it continues with another few turns, and this is the ground, and this is your control, and this is the high voltage. So estimating the number of turns for the high voltage is multiply the voltage of the second of this high voltage here, V2 divided by V1 is equal to N2 over N1. So for this one, high voltage for ignition coil is roughly 2000 volts. So you have 2000 volts divided by, so with the voltage here induced when the engine is running, well, maybe it's only 1 to 2 volts, so 2 volts. So the factor of this one is 1000, so it's equal to 1000. So you multiply this one with the number of turns on this end here. When you cross multiply, then you will get, then you will looking for the number of turns on the secondary, on not the secondary but the high voltage, by multiplying the factor by N1. So N1, because having only 2.6 millihenry on this end here, so you roughly, maybe the number of turns is only 10 to 20 turns. So you multiply it with this 20 turns, and you will get 20,000 turns. If it's 15 turns, it's 15,000 turns. That's why this estimated the number of turns on this high voltage is roughly 10,000 to 20,000 turns. That's a lot. And with that size of coil, size of wire, you're looking maybe number 34 American wire gauge up to or down to number 40 maximum. So it's just roughly around that area. So I hope that makes sense. Now let's show you with this one. So we'll do our resistance reading with this faulty ignition coil, and let's set this one to 20k. So measuring from here to there, to this end, so you get 2 kilo ohms, which is good, which is fine. It seems good, isn't it, right? So, and also measuring from here to there, and we set this one to 200 ohms because this one's a very low resistance reading, so we get 3.3 ohms, and it seems good. So with the normal reading, and also we test this one from here to there, and we should get around 2 kilo ohms reading. Also a little bit of loose contact. So yeah, 2.2 kilo ohms reading, and here is, that's what we saw before, it's roughly 2.2 kilo ohms reading. So with the proper method of testing ignition coil, as far as you know, as far as they know, this one is good, but actually it's not, and I'll tell you why. So we use inductance measurement. We set this one to Henry. So with this to there, so we get roughly 0.8 or nearly 1 Henry. So which is fine, which is good for this type of, the size of ignition coil, which is, we expect the less voltage with this one. So and also, I mean, less inductance, but the voltage is roughly pretty much the same voltage, 2000 volts, but because of the smaller engine, the RPM is quite higher than the mower. So that's why the more RPM, the more voltage induced into the coil, and it gives more the same amount of roughly high voltage with a less inductance on the ignition coil. So now we measure from here to, okay, let's measure from here to there on that end. We should get roughly the same inductance reading of nearly 0.8. Yeah, 0.8 Henry. And we measure from here to there. So this is our measurement from this point here. Okay, we measure from here to there. You get 0 millihenry, which is shorted. And this is why this ignition coil is not working. And I guarantee, I'm telling you the truth, that that's why I place a mark here, because I can't get this one working. It's because it's faulty, and after replacing with another ignition coil, it works fine. So this one's definitely faulty. As I'm telling you, this is faulty. And you see that in millihenry, we set it to millihenry. In millihenry, we also have 0 reading in millihenry, which is like you're shorting this part here. And you're surprised why we get roughly 3 to 4 ohms reading on this part between here and there, because this one has an internal resistance also. So this part here has an internal resistance inside, which gives you 3 ohms roughly. And we measure from here to there with the resistance reading, you get 3 ohms, but the actual coil is shorted, so 0 ohm, which gives you no reading in millihenry for the coil. So this one is like you're having ignition, having engine with the switch always off position, always on the off position. So that's why you can't get the engine running with this one, because it's simulating that the switch is already on the off position. So why the ignition, why we able to switch off the ignition when we short this part here? This is because we shunt all the energy of the ignition coil to this winding, and if we short this one, most of the energy, most of the current will be drawn in this control winding, when no energy will go into the high voltage, and that's the way to switch off the engine. I hope that makes sense and it helps you to, and if this is the first time that you find it out, this way of testing ignition coil, then thank you for that. And this one is also for the Bridgestone Straton 500E series engine, and we try to test this one with inductance meter from this end to this far end here to the high voltage. We should get roughly in henries. So we have 11.22 henries. The more henry, the more high voltage it produces. So because of the more high voltage it produces, they compensate that by reducing the high voltage by adding a resistance on this end here, and allows to have a very nice high voltage ignition spark, and also prevents the emissions or the spike or the transient emissions from radiating and interfering with other devices. So this one's also, we test this one from this end to the control point. We set it to millihenry, so we get 3.56 millihenry, which is good. So this ignition coil is working, it works fine, and this is good. So 3.56 millihenry. Some of the Bridgestone Straton like this, and the control winding is not necessarily to be in less than 5 millihenries. This one is roughly in around 200 millihenries, which is 2.2. Actually, it's 2.2. Okay, sorry, I have incoming call and I have to put this one on hold. Thanks for watching. I hope you enjoy our video repair tutorial for today and regarding ignition, testing ignition coil. And the one I say about 230 millihenries in some of the ignition coil is actually one for the FS36, still FS36, which you measure 230 millihenry between the control and the ground, and it's roughly 2 henries to the ignition high voltage. And same thing with the new replacement FS45, FS38 ignition coil, and it measured the same thing. So yes, this some other ignition coil measures in the range of 200 millihenries, and most of the ignition coil on the lawnmower measured roughly at 2.5 millihenries. So I hope you find it useful and you everything makes sense, and you found this one quite interesting, and I hope you enjoy our tutorial for today. And thanks for watching. Please don't forget to subscribe to our channel, leave a comment, and I'm happy to answer some questions. And thanks for watching, and see you next time. Bye for now.